Welcome to BSc Statistics students. So in this class, I explain the changes in the elements of coefficient matrix Aij, in which already we have discussed uh, case 1. That is, case 1 is if AK does not belongs to B. This is case 1. I have explained this. We have discussed this one in the previous class. And now I discuss case 2. Okay, this is in the post-optimal analysis, and what would be the post-optimal analysis for case 2? That is, if AK belongs to B. See the case 2 is this. If AK belongs to B, that the change in ARK belongs to the basis matrix B. Then both are affected. The current optimum solution XB and the optimality condition ZJ minus HA, both are affected. Okay, in previously in the case 1 only optimality condition is going to be affected. Optimality condition is going to be affected. And now we have to discuss two particular things here because both are affected. The feasibility and the optimality. First one, the feasibility and the optimality. In this class, I explain only the feasibility because the cases are it takes too much of time. So right, the condition for maintaining the feasibility of the solution in this case too. That will let us consider B is equal to B1, B2, and so on Bm. Okay, and where Bj belongs to the A. Okay, A is the coefficient matrix. You have to remember clearly there are the m column vectors we are considering in the basis matrix B. The A belongs to only the basis matrix B we are considering here, the coefficient of A, in which we are considering B1, B2, and so on Bk and so on Bm, which are the column vectors we have considered, which means of the coefficient matrix of A. Okay, and B inverse, the inverse of B, it is going to be considered as beta 1, beta 2, beta k, and so on beta m. So here again we have considered m column vectors in which beta 1, beta 2, and so on beta k, beta m are the column vectors we have considered in B inverse, in the inverse of the matrix. Since AK belongs to B, and any change of ARK will be affected the kth column of B. That is the reason why we are considering one of the column vector Bk in which you have the ARK, the element of ARK. So therefore, to look after the post-optimal changes, the changes in B by indicating B star. Okay, after the change in ARK, that is one particular element of the coefficient matrix ARK is going to be changed, then that is ARK plus delta ARK, then it is B star. Before that ARK, it is B. Hope you understand. B is before the changes and B star is after changes. Then we get B star is nothing but B1, B2, and so on Bk star, Bm. Only the change is Bk star. Previously it is Bk. That's all. Only the requirement is that is change is Bk star. Before change is it is Bk. That is previous old value, original value. Later on changed values Bk. It is in Bk star. Therefore, if you write Bk star, what is Bk star? B1k, let it be. Let us consider B2k and so on Brk plus delta ARK. Delta ARK is nothing but the change is going to be represented in the element Brk. That is, if you consider in the fashion that it represents Bk, B1k, B2k, Brk, Bmk, and then Bk star is nothing but only the change is Brk plus delta ARK. Delta ARK is the change, it is represented, right? And then thereafter, Bk star can be expressed as a linear combination of the basis vectors of B. So if you consider is a linear combination of B1, B2, and so on Bm, m column vectors, and if you express as Bk star is equal to a linear combination where you consider lambda, you know the linear combination, it is C1 x1 plus C2 x2 plus and so on plus Cn xn etc. like that's a linear combination. Here I'm considering bk star is equal to lambda 1 b1 plus lambda 2 b2 and so on plus lambda k bk and so on lambda m bm, where bk star is equal to b into lambda. If you multiply b with lambda, then you will get this, that's all. What is b? b1 b2 bk bm. This is what the column vector, that is basis matrix B. And if you multiply with lambda, that is lambda 1, lambda 2, lambda m, then you will get this in simple fashion, simple way. Bk star is equal to lambda 1 b1 plus lambda 2 b2 plus and so on plus lambda k bk plus and so on plus lambda m bm. Right. So therefore bk star is equal to b into lambda, and where if you want to calculate the lambda, that is another important calculation. Lambda is equal to b inverse bk star. So just it's a matrix multiplication. You multiply with b inverse bk star is equal to b inverse b into lambda. B inverse b is equal to I, the identity matrix, multiplied by lambda. So therefore this is lambda is equal to b inverse bk star, small bk. So b inverse multiplied by what is bk star? Bk star is nothing but, as you refer this is one particular vector bk, b1k, b2k and so on brk and so on bmk, plus if you divide with 0, 0, 0, delta rk 0. So because the change is delta rk. So b inverse into bk plus b inverse bk star is b inverse into bk plus 0, 0, 0 and so on delta rk and so on 0. So it is can be expressed as is equal to b inverse bk. I'm taking one particular multiplication, and plus b inverse into 0, 0, 0 and so on delta rk and so on 0. So this is what the first calculation, and then if you consider b inverse bk and plus b inverse is beta vector, beta 1, beta 2 and so on beta m multiplied by 0, 0 and so on delta rk 0. If you multiply this, you will get only beta 1 into 0 etc beta 2 into 0 and so on beta k into delta rk will remain, and remaining all zeros, and so on beta means 0. So beta k, of course you remember it's beta k is a vector, beta k multiplied by delta rk. So you see here the b inverse bk multiplied by beta k into delta ark. Okay, and then now you have to consider lambda. That therefore lambda is equal to b inverse bk. We can write this as an identity matrix while considering this ek. Ek is nothing but ek is equal to b inverse into bk. B inverse into bk, which gives you beta I, that is the vector beta 1, beta 2, beta m multiplied by bik. I is equal to 1 to m. Right, bik, the value here b1k, b2k and so on. Right. And where lambda, therefore lambda is equal to it is nothing but ek plus beta k into delta ark. You remember this, lambda is equal to ek plus beta k into delta ark. Right. While if you continue this, lambda is equal to, you consider lambda is a vector. Lambda 1, lambda 2 and so on lambda k and so on lambda m, which is equivalent to be it is going to be considered as 0, 0 e. What I am considering ek. Ek is 0, 0 and so on 1 and so on 0. This is kth element. It is going to be considered as 1 because ek identity matrix. That is the vector here in the identity matrix. It is one column vector ek. That is kth column vector 0, 0 and so on 1 and so on 0. Plus beta k. Beta k is beta 1k, beta 2k, beta kk, beta mk. That is beta k multiplied by delta ark. Have you understand? Just it is an explanation for this expanded v. Delta lambda is equal to ek plus beta k into delta ark. Lambda is equal to ek. We have considered kth vector of the identity matrix plus beta k, that is inverse. In the b inverse, it is a kth column vector. Delta ark, it's an element. Change in the ark. That is one of the element in the coefficient matrix. That is what this explanation. Lambda 1, lambda 2 and so on lambda k and so on lambda m. okay, is equal to 0, 0, and so on 1, and so on 0. So ek plus this is beta k, beta 1k, beta 2k, beta kk, and so on beta mk multiplied by delta ark. This is what lambda is equal to ek plus beta k into delta ark. Now you multiply. If you multiply with this the lambda I, for example, you consider I am separating two particular values, lambda I, which I is not equal to k. When remaining all the values are going to be considered here, and except if I is equal to k, then separate value, right? So you consider, you multiply with, you will get it the 1 plus beta lambda I. For I is equal to k, only one value, 1 into beta kk, 1 plus beta kk into delta ark. That is the I is equal to k value. Lambda I, I is not equal to k, then remaining values are there is 0. First two value is 0 plus beta ik multiplied by delta ark. Delta ark is a one particular value change in the ark, and beta ik into delta ark. That is beta 1k delta ark, beta 2k delta ark, except I is equal to 1, 2, 3, and so on. Except I is equal to k. If I is equal to k, then you will have a 1 here, 1 plus beta kk delta ark. That is the value of lambda I. So I write lambda is equal to beta ik delta ark for I is not equal to k. For I is equal to k, then 1 plus beta kk delta ark. If I is equal to k, that is this element, 1 plus beta kk into delta ark. So these are the values of lambda and lambda k. Hope you understand. Then for maintaining the feasibility of the new solution, we should have to consider xb star is greater than or equal to 0. Previously it is xb, now that with the change it is xb star. We have to maintain this. We have to continue this, and we have to maintain xb star is greater than or equal to 0. If it is greater than or equal to 0, feasibility is going to be maintained. Then where we have to consider B star inverse. The B star inverse exists only if B star is non-singular. Obviously, it's mathematically it is true. So must have to consider lambda k is not equal to 0. For which lambda k must be not equal to 0, you have to consider. To make it is non-singular, is to take it is non-singular. So xb star can be expressed as xb star is equal to B star inverse B. What is B star inverse? EB inverse B. B star inverse is EB inverse. That is what we have considered very clearly, right? So EB inverse into B. So in which we have to consider BK star is equal to lambda 1 B1 lambda, it is already we have considered BK star is equal to linear combination lambda 1 B1 plus lambda 2 B2 and so on lambda k BK and so on plus lambda m BM, in which now we have to calculate lambda k, the BK, we have to calculate BK. So for which we are keeping lambda k BK here, remaining all the terms I'm taking the left hand side, so that lambda k BK is equal to minus lambda 1 B1, we are taking left hand side, minus lambda 2 B2 and so on. This is kth element we are writing here, kth vector here, of course. So bk star the element here, minus and so on, minus lambda m bm. This is also you are taking left hand side. Only the term lambda k bk we are keeping here, and with the help of this we are calculating bk. Bk is equal to minus lambda 1 by lambda k into b1 minus lambda 2 by lambda k into b2. So we are dividing with lambda k. So and so on, plus this is only the plus 1 by lambda k. There is no lambda value here. 1 by lambda k multiplied with bk star and so on, minus and so on, minus lambda m by lambda k into bm. So this is what the matrix, in which the matrix E differs from the identity of the in the kth column. So whichever you consider E, that is identity matrix we are considering. Only the one particular value is going to be deferred. That is kth column, kth vector, this particular 1 0 0 0 and so on. Next second one 0 1 and so on 0 0, and then this is the value here, minus lambda 1 by lambda k, minus lambda 2 by lambda k, and so on 1 by lambda k. This is Okay, 1 by lambda k, that is bk, coefficient of bk, and it is going to be considered here, and that is what e, it is going to be taken, and so on and so on, minus lambda m by lambda k into lambda k, minus lambda m by lambda k multiplied to bm coefficient, this, and so on and so on, 0 0 0 and 1. So this is what the identity matrix E, that is E I am considering basis in the basis, and where lambda k is not equal to 0. If lambda k is 0, then entire problem will be not going to be existed. So the lambda k not equal to 0. The optimum solution after changes of xb star is obtained by, finally, if you see what you have to consider, you have to maintain xb star must be greater than or equal to 0, for which we are doing entire this. So xb star is equal to E into B inverse B. xb star is equal to E into B inverse B. Alright, so xb star is equal to E into B inverse B is xb. So this is xb is previously, it is the solution, optimum solution. That is to maintain the feasibility. That is xb is the optimum basic feasible solution in which the values of xb, right? And E is nothing but just now explained, and xb star is equal to, let us consider xb1 star, xb2 star, and so on, xbk star, xbm star. So which is going to be calculated by, our intention is xbk star, right? So 1 0 0 0 at 0 1 0 0 0, I'm studying in terms of column vector, minus lambda 1 by lambda k, minus lambda 2 by lambda k, and so on 1 by lambda k, and so on minus lambda m by lambda k, and last vector 0 and so on 0 0 0 and so on 1, right? Multiplied by xb is xb1 xb2 xbk and so on xbm. So if you multiply these two, what you will get, xbi, that is except k. If I is equal to k, only separate value. Remaining all we have another value, that is I not equal to k. Then you will have, if you multiply with 1 into xb1, 1 into xb1 minus lambda 1 by lambda k into xbk. That is if you consider first one, second one, and so on. 1 into xb2 and so on, minus lambda 2 by lambda k into xbk, remaining all zeros, 0 0, and similarly, and then xbk and xbm is also like that, 1 into xbm minus lambda m by lambda k into xbk. So this is the value for I is not equal to k. For I is equal to k, xbk star is equal to xbk by lambda k, that's all, xbk by lambda k. Now if you see properly, what would be the value of this, it is going to be considered xb1 star is equal to, that's what I have explained in the multiplication, xb1 minus lambda 1 by lambda k into xbk, similarly xb2 minus lambda 2 by lambda k xbk, and so on xbk by lambda k. This is the value only, do not have two terms, I is equal to k term, kth term. And so on xbm minus lambda by lambda k xbk. If you write I is not equal to k, if you write xbi star is equal to xbi minus lambda I by lambda k into xbk. xbi we are considering, for example, I is equal to 1, xb1 minus lambda 1 by lambda k xbk. xbi minus lambda I by lambda k into xbk for I is not equal to k. And for I is equal to k, xbk by lambda k, xbk by lambda k is equal, where I is equal to k. Now you substitute the values of lambda I and lambda k, already we have calculated. I show you lambda I and lambda k we have calculated here. So lambda I is the value beta I k delta r k for I is not equal to k. Lambda k is equal to, I is equal to k, 1 plus beta k k delta r k. You substitute these values here, and then you will get in the linear combination lambda I lambda k. If then you will get xbi star is equal to xbi minus lambda I by lambda k minus lambda I by lambda k. Lambda I is equal to beta I k delta r k divided by 1 plus lambda k 1 plus beta k k delta r k multiplied by xbk. I is not equal to k, and then second one xbk by lambda k, xbk by 1 plus beta kk delta rk for I is equal to k. So these are the values of xbi star. So now For maintaining the feasibility, xbi star must be greater than equal to 0. That is what I'm explaining again and again. For xbi is greater than xbi star is greater than equal to 0, in which only the element xbi star is going to be greater than equal to 0. We have to prove it, and for all the values of I, then if you consider what is xbi star, we have calculated. Xbi star is nothing but xbi minus beta ik delta ark divided by 1 plus beta kk delta rk, it is greater than equal to 0. Then if you take this particular term right hand side, xbi is greater than equal to beta ik delta ark xbk divided by 1 plus beta kk delta ark, right? In which what you have to calculate is range of delta ark, then ark. This is our intention. What would be the range or the values of delta ark, so that feasibility is not going to be changed. The feasibility is to be maintained, optimality is to be maintained, you please remember. So therefore xbi into, you multiply this with here 1 plus beta kk delta rk is greater than equal to beta ik delta rk xbk, and so that you consider, you take this delta ark term on the right hand side, and remaining values you consider here. So therefore xbi plus, you multiply with 1, xbi with 1, and xbi into beta kk delta rk minus beta ik, if you take this particular term left hand side, beta ik delta rk xbk, and delta ark you take common in these two terms, delta ark into xbi beta kk minus beta ik xbk, okay, is greater than or equal to minus xbi. So therefore delta ark is greater than or equal to minus xbi divided by this, that is beta kk xbi minus beta ik xbk, right? So therefore already we have discussed this is many number of times, and since this is lies in between, therefore delta ark lies in between maximum of this. If you consider beta kk xbi minus beta ik xbk as qi, if you consider as qi, and qi, if qi is greater than 0, this is delta ark greater than or equal to minus xbi by qi, and qi is less than 0, then delta rk less than or equal to minus xbi by qi. So therefore for maintaining the feasibility, it requires delta rk must be lies in between these two, maximum of minus xbi by qi greater than 0, less than or equal to delta rk less than or equal to minimum of xbi minus xbi divided by qi is less than 0. This is what the condition of feasibility. To maintain the feasibility, we have to consider the range of delta rk must be in these two particular limits, okay, that is where qi is this, all right. So this is what the feasibility condition I have explained in this class, and I explained optimality to maintain, what is the condition for maintaining the optimality, okay, of case 2 I discuss in the next class. Thank you very much.